Hello class, we are going on to section 12.2 over surface areas of prisms and cylinders. So surface areas include pretty much everything that's on the touching part of your prisms or cylinders. So we're going to talk about lateral faces, and those are parallelograms formed by connecting. So this is parallelograms formed by connecting the corresponding vertices of the bases. Our next definition is lateral edges, and these are segments or line segments connecting the vertices. So segments connecting the vertices. Our next definition is surface area, and that is the sum of the areas of its faces. The lateral area is the sum of the areas of its lateral faces. So a net is a 2D representation of the faces. So this is where if I took a 3D figure and I were to open it up, kind of like origami before you fold it back in, it's a 2D representation. A right prism is where each edge and I'm talking for a lateral edge. So each lateral edge is perpendicular to both bases. An oblique prism. So oblique is a prism with lateral edges. So remember, a prism kind of has two faces on it, or two bases. So think prism has two bases, whereas a pyramid, it goes to one point, like the Great Pyramid in Egypt, for example. A right cylinder has a segment joining the centers of the bases and it's perpendicular to the bases. That's a right cylinder. And our last definition is an oblique cylinder, and that's a segment not perpendicular to the bases. So a segment not perpendicular to the bases. And so this is our full page of definitions for surface areas of prisms and cylinders. So if we go on to our next page, we'll have a couple of core concepts, theorems, and extra examples. So on to our next page, we have core concepts of lateral area and the surface area of a right prism. For a right prism with the base perimeter P, a base apothem A, and then a height for H, and a base area B, the lateral area L, and surface area S are as follows. So you have the lateral area is equal to the perimeter of the base, so that's why it says base perimeter times its height, whereas the surface area is 2 times the base, or if we have an apothem, the apothem times its perimeter plus the lateral surface area, which is the same as the base perimeter times its height. So moving on to our first example, and so we have a triangular prism, or in this case we have a right prism. And so we're going to find the surface area as well as the lateral area. So let's start with the lateral area first. So we know that the lateral area is equal to the perimeter times its height. So let's start off with finding the lateral surface, or the lateral area. So I have L equals the perimeter times the height. And so our base perimeter in this case is a triangle. And we know with triangles, because of the hash marks, we know that each side is going to be 6. So the perimeter is 6 times 3, because I have 6 centimeters and I have 3 sides. And then the height is also going to be 6, because each side is also 6 as well. So I have 18 times 6, and I get 108 centimeters. Okay, so 108 centimeters is our lateral area. So let's say we want to find the surface area. So surface area is 2 times the base area plus the lateral surface area. So now we got to use 108. However, we got to find the base area and multiply by 2. So in order to do that, I'm going to kind of take one of my faces, or take my base, and I'm going to draw a separate triangle in order to find the area. So here is my face, and I know that each side is 6. Okay, and I need the height, because the area of a triangle is 1/2 base times the height. So if I were to take this, I need to find the height of this triangle. And I know at the bottom is 6, but I cut it in half, so I end up with 3 and 3. So this is where I took 6 and I split it down the middle in order to find the height. So note, with most of this, I have a special right triangle. And with special right triangles, in this case, I have a 30, 60, 90. So 30 and 60 and then 90. So I have this equals 2x, and so that means x equals 3. So this concludes, so if I want to find the height is 3 square root of 3. So because it is x square root of 3. So this is where we came back using special right triangles again. So these have 30, 60, 90 triangles. And so now I can fill in the rest of my blank. So B for the base area is 1/2 the base times height. So 1/2. And our small base is Amy. Pardon the announcement. So I have 1/2 times my base, and we know the base is 6, and then times the height, which we know is 3 square root of 3. And so I can take 3 times 6, which is 18, and 18 divided by 2 gives me 9. So I have 9 square root of 3 for the base area. So now I can plug in the base. So I have 2 times 9 square root of 3 plus the lateral surface area, which is 108, which we found earlier. So I have 18 square root of 3, because 9 times 2, plus 108, and if I want to type this all into the calculator, I have 139.18 centimeters. Okay, so that is a long example using special right triangles in order to find the height of a triangle. So if we're going to scroll down to our next section, we're going to use lateral area and surface area of a right cylinder. So to a right cylinder, we're still dealing with circles, so we are going to be using pi. So lateral area is 2 times pi times the radius and its height, where the surface area is 2 times the base, and the base here is going to be your pi r squared. So these two mean the same thing. Okay, so let's do one example. So we're trying to find L, which we know to be 2 pi r h. So we have 2 times pi, so that's already a given. And then the radius here is 4, and then the height is 8. So we end up with 4 times 8 times 2, which gives us 64 pi, and as a decimal you get 201.06. So that's for lateral surface area. Now if we want the surface area, we already know we have 2 times the base, or we can do 2 pi r squared plus L in this case, or 2 pi r h, which we already found to be 201.06. So 2 pi, and then r is 4, and we're squaring it, plus 201.06. So we have 96 pi, or you can also say this to be, you have 16 times 2. So 16 times 2 is 32. So you have 32 pi plus 201.06, or you can say 64 pi, and you end up with 96 pi, or as a decimal is 301.59. That is one way of finding the surface area. You can either put it as a decimal, or you can use 64 pi. Okay, so that completes the core concepts, and so let's move on to some extra examples. Okay, moving on to extra practices. 1 through 3 says we need to find the lateral area and the surface area of the right prism. So for number 1, remember we talked about lateral area is the perimeter times the height, and then the surface area is 2 times the base area plus that lateral surface area. So we're going to be using these two in order to answer questions 1, 2, and 3. So the lateral surface area, so we have 4 times 3, because we have 3 sides. Remember the perimeter of this triangle. So we have 4 for each part. So 4 times 3 is the perimeter, and then we have the height, which is 7.2. So in our calculator, we get 12 times 7.2, and you end up with 86.4. So that is lateral surface area. Now we're going to take the surface area. Now, because we have this triangle again, we're going to do what we did in the previous example. So I'm going to redraw the face, and I'm going to cut it in half because I need to find the height. So I have 4 and 2. So the height, if we know that this is 2x, and we're divided by 2, that means x is 2, so this is correct. And then remember, we have 2 square root of 3 because this is an x square root of 3. So 2 square root of 3 is our height. So for the base area, we have 1/2 base times height. So 1/2, the base we know to be 4, because 2 and 2. And then the height is 2 square root of 3. And so we have 4 divided by 2, which is 2, times 2 gives us 4, so we're left with 4 square root of 3. So that is the base area. So S equals 2 times the base area, which is 4 square root of 3, and then plus our 86.4, and you end up with 8 square root of 3 plus 86.4, and as a decimal, you end up with 100.26 in your calculator. So that is example 1. Now example 2, giving you guys time to write, we're going to do the same thing. So now for perimeter, pardon the announcement, so doing the same thing, our lateral surface area is P times H, so the perimeter, so remember perimeter for a rectangle, this is a rectangle that we have, perimeter is 2 times the length plus 2 times the width. So I have 2, and our length is 12, that's how long it is, and our width is 6. So we have 24 plus 12, which gives us 36. So the perimeter is 36, and then the height is 3. So 36 times 3 gives us 108 centimeters. So that's the lateral surface area. And now we need the surface area, the lateral area. Now we need the surface area. And so remember, the base area is length times the width of our base. And so we have 12 times 6, which gives us 72. So 2 times 72 plus our lateral surface area, which is 108, gives us 252 centimeters. So that is for example 2. Now going on to example 3, we do not have any pictures. It only gives us specific information. So we know we have a regular hexagon, and remember a hexagon is 6-sided. That's a 6-sided figure, and it has a height of 25 feet and a base edge length of 14 feet. So bear with me on this one. So we need the lateral surface area, or the lateral area, which is perimeter times the height. So remember, the perimeter is each edge is 14 feet. So where each edge is 14 feet, and then we have each side, or how many sides it has, and so it's 6. Remember, in this case, the perimeter is n times s for a regular polygon. So the number of sides times how long each side is. Each edge is 14, or each side is 14, and it's a 6-sided base. So 14 times 6, and then it says the height is 25, and so the lateral area is 2100. So that's the lateral area. Now to find the surface area, remember we have 2 times the base area plus the lateral surface area. So in this case, if we have a hexagon, let's say we have to find the apothem, and it says 2, it's the base edge is 14, so that means the radius is also 14. So if I want to zoom in on that particular part of this, I do have a triangle, so 14 and 14. And if I were to cut this down the middle, I end up with 7 for that edge. So if I have 2x, x, and then I have x squared root of 3, that means the hypotenuse, or not hypotenuse, the height, or the apothem in this case, is 7 square root of 3. So remember, this is from 2x equaling 14. So that means x will equal 7, and 7 square root of 3 is what our apothem would be. So for a triangle, remember we have, or for the apothem for a regular polygon is 1/2 the apothem times the perimeter itself. So 1/2 times the apothem, which is 7 square root of 3, and then times the perimeter, which we already found to be 2100. or not 2100, we found that to be 14 times 6. My apologies, remember the perimeter is 14 times 6. So 14 times 6 is the entire, or the perimeter part in the likeness. I'll rewrite it here. So now we can take all of this and plug it into our base area. This is the base area. So we have 2 times 1/2 7 square root of 3, and then times the 14 times 6, and that's all the base area. So 2 times half cancels out to give me 1, so I'm really just left with 7 square root of 3 times 14 times 6, and then we add this to our 2100. And so when we're left with that, the 2's cancel out, so I'm left with 14 times 6, which is 84 times 7. So I get 588 and square root of 3, and then plus the 2100, and I end up with 3,118 and 0.45 if we're rounding to a second decimal place. Okay, so I got 588 by multiplying 14 times 6 times the 7, so I got 588. Remember the 2 and the half cancel out, and I kept the square root of 3, and then I add it to 2100. So that is finding the surface area. Now we're going to move on to questions 4 and 5. We need to find the lateral area and surface area of the right cylinder. So a right cylinder, so remember for this one we are using the lateral surface area to be 2 pi r, or times the radius times its height. And so 2 pi, the radius is 6, and then the height is 5, and so I'm left with 60 pi, or as a decimal, 188.5. So knowing that 6 is the radius and 5 is the height. So to find the lateral, or the surface area, remember we're taking 2 pi the radius squared and then plus 60 pi, which is our lateral area. So we have 2 pi r is 6, and we're squaring it, plus our 60 pi, and this equals 72 pi plus 60 pi, and as a decimal, or in terms of pi, you get 132 pi, or 414.69. So that is surface area. So all you're doing is plugging in that squared. A lot of this is plug and chug as we go. Number 5, same concept, except we're given the diameter. So remember the radius in this case is going to be 12. So we have L equals 2 pi the radius, which is 12, times the height, which is 52.8. And so we are left with 1,267.2 pi, or as a decimal, we get 3,981.03. The lateral area is simpler. When we get to the surface area, that's when we have to add an extra step. So now we have 2 pi r squared. So I have 12 squared plus our 1,267.2 pi. I'm going to leave it in terms of pi because I have both pi's here, and I can always do pi at the end. So I end up with 288 pi plus 1,267.2 pi. I end up with 1,555.2 pi. And as a decimal, I end up with 4,885.80. That's a 5. Okay, so a lot of this is plug and chug and knowing those formulas like 2 pi radius times the height, as well as knowing what that lateral surface area is as well. Okay, so our last one, number 6, it says the right cylinder has a radius of 3.6 inches and a height of 15 inches. We're talking about a right cylinder, that's the radius, and it has a height given. And so, remember that lateral area is 2 pi r times the height. So at 2 pi, the radius is 3.6 and the height is 15. So I'm left with 108 pi, or as a decimal, 339.3 for rounding to the 10th place. So the surface area is 2 pi r squared plus 2 pi rh, or the lateral area. So I have 2 pi, and we have 3.6 squared plus our 108 pi, which we already found in our previous one. That's what the L is. So I end up with, as a decimal, 420.72. Skipped a couple steps, but I understand you should know how to square and type most of this into your calculator. So 420.72 is your surface area. And that concludes 12.2 notes. I apologize for the interruptions on the announcements. Thank you so much for watching my video, and have a great day.